Module 2, Data Modeling for Data Warehousing. Data modeling is a crucial step in designing and building a data warehouse. It involves creating a logical representation of the data that will be stored and managed in the data warehouse. The data model provides a blueprint for organizing, structuring, and storing data in a way that supports efficient data retrieval, analysis, and reporting. Here are some key concepts and best practices for data modeling in data warehousing. 1. Dimensional modeling. Dimensional modeling is a popular data modeling technique used in data warehousing. It involves organizing data into dimensions and facts to create a star or snowflake schema. Dimensions represent the descriptive attributes of data, such as time, location, product, and customer, and facts represent the quantitative data, such as sales, revenue, or quantity. Dimensional modeling provides a simplified and denormalized structure that is optimized for efficient querying and reporting, making it well-suited for data warehousing. 2. Data integration. Data warehousing involves integrating data from various sources, such as transactional databases, external data sources, and data streams. Data integration is a critical aspect of data modeling, as it requires defining how data from different sources will be combined, transformed, and loaded into the data warehouse. This may involve data cleansing, data enrichment, data transformation, and data validation processes to ensure data quality and consistency in the data warehouse. 3. Data granularity. Determining the appropriate level of data granularity is important in data modeling for data warehousing. Granularity refers to the level of detail at which data is stored in the data warehouse. It is important to strike a balance between too much granularity, which can lead to increased storage and processing overhead, and too little granularity, which may result in loss of important details for analysis. Data granularity should be aligned with the specific business requirements and analytical needs of the organization. 4. Data history. Data warehousing often involves capturing and managing historical data, allowing organizations to analyze data trends and changes over time. Data modeling should consider how historical data will be stored, managed, and used in the data warehouse. This may involve implementing techniques such as slowly changing dimensions, SCDs, to track changes in dimension attributes, and maintaining historical snapshots of fact data to support time-based analysis. 5. Scalability and performance. Scalability and performance are critical considerations in data warehousing. Data models should be designed to support large volumes of data and query performance. Techniques such as partitioning, indexing, and materialized views can be used to optimize data retrieval and analysis in the data warehouse. Additionally, data modeling should take into account data distribution strategies, such as data sharding or data replication, in distributed data warehouse environments to ensure optimal performance. These are some key concepts and best practices for data modeling in data warehousing. A well-designed data model is essential for building a robust, scalable, and high-performance data warehouse that meets the data analytics and reporting needs of an organization. It is important to carefully consider the data requirements, business needs, and data governance considerations when designing data models for data warehousing projects. Overview of data modeling. Data modeling is the process of creating a visual or logical representation of data, typically using diagrams or models, to define how data will be organized, structured, and stored in a database or data warehouse. Data modeling serves as a blueprint for designing and building databases or data warehouses, and helps ensure that data is stored in a consistent and efficient manner to support data retrieval, analysis, and reporting. There are several different types of data models, including 1. Conceptual data model. A conceptual data model represents the high-level view of data requirements and relationships between entities in a system, without getting into the technical details of how the data will be implemented. It focuses on defining the entities, their attributes, and the relationships between them in a conceptual way, often using entity relationship, diagrams, or other visual representations. 2. Logical data model. A logical data model provides a more detailed representation of data requirements, defining the structure of the data in a database or data warehouse in a technology-independent manner. It defines entities, attributes, relationships, and constraints in a way that can be easily translated into a physical database design. Logical data models are typically used by database or data warehouse designers to create the actual database schema. 3. Physical data model. A physical data model represents the actual implementation of the data in a database or data warehouse. It defines the specific data types, constraints, indexes, and other technical details that are required to store and manage the data in a specific database management system, DBMS, or data warehouse platform. Physical data models are used by database administrators, DBAs, and data warehouse administrators to create and manage the physical database structures. Data modeling involves various techniques and methodologies, such as normalization, denormalization, dimensional modeling, and data vault modeling, depending on the specific requirements and characteristics of the data being modeled and the type of system being designed. The choice of data modeling approach depends on factors such as the nature of the data, the complexity of the system, the performance requirements, and the intended use of the data. Data modeling is a critical step in the database or data warehouse design process, as it helps ensure that data is organized, structured, and stored in a way that supports efficient data retrieval, analysis, and reporting. Well-designed data models are essential for creating robust, scalable, and high-performance databases or data warehouses that meet the data requirements and business needs of an organization. Dimensional modeling. Dimensional modeling is a data modeling technique used in designing data warehouses, which focuses on creating a logical and efficient structure for storing and retrieving data in a way that supports efficient and effective data analysis and reporting. Dimensional modeling is specifically designed for handling large amounts of data and enabling complex data analysis, making it well-suited for data warehousing environments. In dimensional modeling, data is organized into two main types of tables: dimension tables and fact tables.
Thanks for watching. For more information, like, comment, and subscribe our channel.